This is Breaking Down Security, and I am Brian Brake. Welcome back, listener. This is Brian, Mr. Betcher, and Miss Berlin for Breaking Down Security.
What up?
Hi.
Yes, we're back again this week for another episode after last week's stellar, not off the rails episode with our fellow authors, Mr. Lee Brotherston. Oh my God, that was an awful show.
No, it was the best one yet.
In your mind, yes. Yes.
That's how Lee and I banter every day.
Oh my goodness. Yeah, that was a fantastic show. I would have loved to have put some of the before and after audio in there, but unfortunately we would have lost our R rating that we would have had. It would have been just incredibly awful. And maybe one day I'll release those in the best of. Yeah.
Completely my fault.
Is it? He's a dirty Canuck, boy. He's dirty.
Yeah. He is. That's why we get along so well.
My goodness. So, all right. So we're going to get started here. We have a gentleman by the name of Jason Garbis. Little background on where we got Jason from. A friend of mine, his name is Sean Harris, not to be confused with the now late master of the CISSP books. He was at the ISC Squared Secure Conference in Seattle, and we were talking about software-defined perimeter. And, I was asking him questions about what the difference between it and software-defined networking was. And he's like, hey, you should talk to this guy named Jason who was at the CSA conference and talking about software-defined perimeter. So while I was in ISC Squared Secure Conference listening to some vendor spiel, I reached out to Jason, and he was more than happy to come on the show. So thank you, Jason, for joining us.
Yeah, thank you for having me. And now, we got to set expectations. I thought this was a family-friendly show, so I may need to talk to my agent if there's too much profanity.
No.
Charge extra for that.
No, we'll bleep out all your profanity and we'll leave ours in.
Don't believe him.
No. Yeah, no, we'll keep it clean this week, won't we, Mr. Betcher?
I know. I can just speak for myself sometimes.
Okay, well, right on.
I'll just not talk. We'll just do it that way.
Well, don't be like that. Don't be like that.
I'm joking. I can be good.
All right. Well, Jason, so people who don't know who you are, maybe you could tell us a little bit about yourself, maybe a little bit about your origin story, where you came from, and how you got to be where you're at today.
Sure thing. I'll try to keep it brief. So I've been in the technology industry for about 25 years. Started out as a software engineer, writing C++, Java code in the old days on what's now considered ancient technology, but nonetheless, pretty interesting things. Client server, distributed systems, and I'll date myself. I was an OS2 programmer. And it was great.
Wow.
It was amazing to move from this horrible segmented 16-bit address space in Windows to a beautiful flat 32-bit address space in OS2, and it was just an amazing change.
Very nice.
There you go. So
Okay.
I think I've defined myself pretty well there. I did software engineering for a bunch of different software companies for about 7 or 8 years. Then I moved into a professional services technology consulting role, and then from that ended up doing product management, which I've been doing for about the last, I would say, 10 to 12 years. Most recently in the identity management space, and now here at the current company, CryptZone, in the network security space, in particular focused on software-defined perimeter.
Okay. So we've had, so I know that some people might, long-term time listeners might hear software-defined perimeter and think of the shows that we've had with regards to software-defined networking. Is there any difference between those, or is it just, are they the same, or how are they different?
Yeah, they're quite different, and it's, I would say, a little bit unfortunate that there's so much similarity in the names. So I think we're all familiar with what software-defined networking is, which is essentially you have all these networking components that are traditionally hardware-based, and now they become software-based, and you can mix, match, and change them on the fly. Software-defined perimeter is a specification published by the Cloud Security Alliance, and what it does is it will dynamically create individualized and identity-centric perimeters, effectively network segments on the fly for each user. It does this through essentially an overlay architecture that we'll probably get into in a few minutes. But what it allows organizations to do is to have a much more secure and much more flexible, much more fine-grained way of understanding and modeling and enforcing what users can get access to what resources.
Okay. So during my research for software-defined perimeter, a lot of words came to mind like Black Cloud, Beyond Corp, and deperimeterization. Now, did this start with Google? Because the Beyond Corp stuff is fairly old. I mean, they were talking about Beyond Corp back in like 2007, 2008. Did this start with them, or is this an ongoing a standard that was created and then they just kind of did their own thing with it?
Yeah, you forgot the other buzzword, which is zero trust. So all of these things, zero trust was published in research, and it's a tremendous amount of benefits, and they espouse a new and different way of approaching network security. And I think they're all worthwhile to look at. And obviously, some of them are things that you can accomplish today, like with the software-defined perimeters. We'll talk about there are a variety of vendors. There's even an open source version that's available for folks. Beyond Corp is only deployed at one company on the planet, Google, and they've done a terrific job at it. They've just started, in fact, in the last couple of weeks, offering one piece of that for their Google Compute Cloud platform. Zero Trust is more the philosophy and a pretty high-level architecture, but the principles in there are very well defined, and in fact carried through to both Beyond Corp and into the software-defined perimeter, which is a notion of really not trusting packets. And I'll go on a little diatribe here, but if you think about what TCP/IP does, it's been the principle of implicit trust. Happens it allows anyone across the network, anyone that can send packets, to establish a connection, and then and only then does it try to enforce some sort of authorization and some sort of authentication level. And that's really exactly backwards from how it needs to be in today's world, where you have, as Gartner calls it, the internet cesspool, where you put a server on it, within 5 minutes it's getting attacked, as well as organizations where it's far too easy for adversaries to get a foothold through a phishing link, and you've got all of a sudden malicious users with footholds on the network doing port scans and opening up connections and trying to exploit vulnerabilities. So what the brilliant part of software-defined perimeter is that it reverses that, and it says, you know what, we're not going to let anyone establish a connection to our servers until they authenticate first. So the issue of zero trust, and until you send a proper set effectively. We can talk about how that works in a minute. We're not going to let you connect. We're not going to let you exploit or use up resources on our server, or potentially take advantage of default credentials or known vulnerabilities in our web server or our SSH library or something like that.
So my question is, how is that different than setting up like a roles-based VPN for everybody? They still have to authenticate. They still have rules on what access they're allowed to get to.
So a VPN is designed to solve one particular problem, which is allowing remote users secure access across an untrusted network. What software-defined perimeter does is it solves that problem, but it also does a lot more. So first of all, with we'll call it SDP as an acronym. It's intended to be used by all users at all times, regardless of whether they're on the corporate network or at home, so that you can have this higher level of trust. That's one. Second, it is built around this notion of using both device, user, and overall contextual attributes to make very fine-grained access decisions around what users should get access to. And one of the challenges with VPNs is they typically simply look at individuals and map them onto a VLAN or a large chunk of the network. And organizations either for security purposes or for compliance purposes, really want to get much finer grained control of which services individual users can get access to. And one of the problems is they're really hampered by the very nature of the infrastructure we're working with. It's impossible with a firewall or a traditional type of security solution to express a policy that says Amanda should be allowed to get access to this server over here, because in the firewall rule, you're literally modeling it as this IP address is allowed to send packets to that IP address. And we really don't have any, that's not very meaningful at all.
Okay.
So you mentioned the idea of zero trust. I thought of a couple of questions here. So at many companies, you have the issue of, okay, I can install the VPN client on my work box, but there might be a chance where I'm on vacation and I have my personal box, and they need me to log in and do XYZ. Well, I'll just go ahead and install the VPN client on there and I'll be able to get in. Can things like software-defined perimeter fix the shadow IT issue where it's like, well, the idea is you're not supposed to use personal devices to access things? Can that be locked down? How do you use software-defined perimeter to make sure that only the necessary assets and the necessary people get to the necessary bits? Is it cert based? Is it password based? Is it how do they do that? Is it token based?
A lot of what so the software-defined perimeter specification, the version 1 was published about 3 years ago in 2014, and we're in the process of working on version 2 right now. And as a version 1 spec, it has limited scope. So if you think of it as a broad framework and think about how different vendors or different implementations might choose to do it, I mean, I think the answer to your question is going to be a broad yes, which isn't, I know it's not very satisfying, but we can talk about some examples. So one example might be a corporation might say, I want to have a multi-factor device onboarding process where you can't just install the client on software and type in a username and password. We need to have some out-of-band mechanism that's the IT department or the security department runs. If you do that, then you have a much more secure starting point, and it's going to prevent you from using a personal device or an unauthorized device to access the system, even if you have your username and password. Other organizations might say, no, we want it to be a little bit more open. We'll allow anyone on any device to access, but we're going to require multiple forms of authentication. So we might have username and password, as well as an OTP, perhaps that's generated by their phone, for example. Both of those are perfectly reasonable decisions that would typically be driven by a policy or how the system gets deployed.
Okay. So what's the architecture look like for this? I mean, you have a host, you have host A, you need to get to host B. How does host A and host B make sure that, one, they can connect to one another in a secure manner? Is there a controller? Is there I think one of the diagrams I saw mentioned a security gateway, and how is a security gateway different than a firewall is?
Yep. So the general architecture has three main components, which is a controller, a gateway, or really a set of gateways, and then the user device itself, which is running a small client on it. The way that the system works is the controller acts as a centralized authentication point and policy store, and it's generally connected up to an enterprise's identity management system, whether that's AD or LDAP or SAML provider, and potentially up to their PKI infrastructure. The gateways sit in line in the network in front of the protected applications, which might be on premises in your data center, and they might be running in the cloud. And those applications are not going to be accessible from any sort of network connection or any sort of network packet unless it goes through the gateway. So the gateway acts in some sense as a firewall, but it's a lot more dynamic and smarter than that. So let's go through the process. And again, I'm extrapolating a little bit here because the original specification has certain limited scope. We as a vendor had to fill in the gaps to get an enterprise-ready product. So I can't talk just about the spec. I'll try to keep it generic and speak in a way that would be generic across the different vendor implementations. So in general, when the user connects their device or launches a client application like a web browser or an SSH client, essentially what happens behind the scenes is the device the SDP client will connect up to the controller for the initial authentication. The user might be prompted for a password, or they might not, depending on if it's cached. Controller will validate the user against the identity provider and effectively perform a policy evaluation based on what it knows about the user and what it knows about the target system and what it knows about the overall environment. And through one path or another, we'll send those instructions to the set of gateways. The gateways will then allow the user's device to set up a secure encrypted tunnel using mutual TLS from the user's device to the gateway, and then allow or prevent packets through to the target applications. Different vendors do it a little bit differently, but that's effectively how that works. Does that answer the first part of your question?
Yeah, no, that works. Yeah.
Okay, so if we think about what the idea of zero trust is, we talked about, and I built it up a lot, right? Which was we're turning things on their head, and we're saying you're not connecting first and then authenticating. You're authenticating first and then connecting. And we've accomplished that with the protected servers, because you can't connect to the servers unless you pass muster. You've been authorized, and there's a policy that says. But then, of course, the counter argument is, well, great, but what about the controller and the gateway? Aren't those exposed? Mm-hmm. And the answer is that the designers of SDP are using this thing called single packet authorization. And this is something that evolved from this concept called port knocking.
Yep.
And effectively what happens is, through a specially crafted single packet that contains a cryptographically signed message authentication code, that allows the client to send this packet, so it's a very small amount of data, and allows the controller and the gateway, with very little computational load, to validate whether the client has effectively the shared secret and has created the proper packet. So it allows the systems to very easily and very quickly, without a lot of compute power required, to make a decision about whether this is an authorized client and they should allow the connection to get established, or if it's an unauthorized client, they should reject it.
Okay. So you mentioned TLS encryption. So is there a way to spoof the packet that gets sent? And is it the same value in the packet every time, or is it randomly generated? How do we keep that from being like, if I grab that one packet off of that guy's box, or I can intercept that packet in transit, how do we keep from having replay attacks or spoofing attacks to allow somebody to gain access to assets they shouldn't?
Yeah, so effectively, it's there's several fields in the packet that, one of which is a counter and one of which is this hashed message authentication code that will prevent replays and prevent spoofing.
Okay.
Yep.
And do you see? Sorry, go ahead.
Yeah, go ahead, Amanda. Go ahead.
Do you see people replacing, like using this as an add-on to their infrastructure that they already have, or replacing components with it?
What we're seeing is, it really depends on the organization. We're absolutely seeing people replace VPNs, because there's no reason to have a VPN when you have a software-defined perimeter in place for individual users. We aren't seeing organizations go crazy and say, you know what, I'm going to get rid of all my firewalls. But what we are seeing them do is dramatically simplify the number of firewall rules, the complexity, and therefore the amount of labor that is required to do that. We have one customer, which is a pretty large organization. They have about 20,000 users on this. And they had, prior to the system, they had 8 full-time people required to operate their firewalls and their VPN solution and all of this other infrastructure. And once they deployed this, they're able to reduce that to 1 FTE and free up those 7 people to work on more value-added activities. They weren't fired.
I was just going to say something about you saturating the market with network engineers, but
I don't think that's going to happen anytime soon.
So is there 2-factor authentication with this as well?
There is. Typically what we see is organizations, for the device onboarding process, want to have 2. And then oftentimes what happens is they don't want to overburden the user. So they'll have the step-up authentication happen driven by policy. And a simple example is, in order to access System X, the policy might say, if you're on the corporate network, you don't need to do anything other than initially authenticate once with your username and password. But if you're remote, we're going to prompt you for an OTP when you access this system. That's a perfectly reasonable policy. There might be other conditions where, if you haven't entered an OTP in a while, or if you're, accessing some combination of applications, for example.
Okay. So let me ask you, during you and I actually met before the podcast. We met in secret, without Miss Berlin and Mr. Betcher getting in the way. I mean,
the stories you told me about them, Brian.
I know. I'm
Oh,
sorry.
man.
Oh man, ratting me out. Anyway, so one of the things when I was looking for research was software-defined perimeter. Of course, I started at Wikipedia, and some of the things, and you can answer, you can talk to some of this, but. According to the software-defined perimeter Wikipedia page, they said that software-defined perimeter will mitigate most common network-based attacks, including server scanning, denial of service, SQL injection, operating system and application vulnerability exploits, man-in-the-middle, cross-site scripting, cross-site request forgery, pass the hash, pass the ticket, and other attacks by unauthorized users. Now, that sounds like it sounds really great. I mean, why doesn't everybody use software-defined perimeter if we can get rid of cross-site scripting and cross-site request forgery stuff?
That's quite a laundry list of things that I think we probably left off. I don't know, growing old and halitosis as well.
Yeah.
So I think I don't want to enumerate the list and try to talk about each one of those, but clearly what's happening is when you have a secure encrypted connection with mutual TLS from the user's device to the gateway, you eliminate the possibility of man in the middle because both sides are validating each other's certificate, and you're guaranteed that things aren't getting tampered with along the way. You're absolutely reducing your attack surface as an organization because now only authorized users can see these services on the network. You're not allowed, and because you have generally fine-grained policies that might say, for example, well, Jason can access this server, but only on port 443. Amanda can access it on port 443 and port 22. I can't even attempt to open an SSH session there and do something malicious because that's blocked. Now, there's limits to this, of course, but if you know that, number one, you've only allowed authorized user to access it, then you've made it a lot harder for the attacker. If you've removed the capability of anyone to sniff this traffic or tamper with it, you've reduced the attack surface further. And
so,
what were some of the? Yeah, go ahead.
So how you've talked about it, like it's super in depth and fine grained policies and everything. How difficult is that to tap down and figure out what each individual person or group or whatever needs?
That really depends on the vendor implementation. And the only reason I'm hesitating is that in the spec, there's no mention of a policy model. That's simply outside the scope of the spec.
Okay.
And that's something that we're at the beginning of version 2 of the spec. And that's something that I'd like to include in there. It really
have
depends.
You'd have to know your network and know you'd already have to be pretty advanced in your processes and procedures and security already to know all of that stuff to get it implemented correctly.
Well, no, I'd push back on that a little bit. I mean, it depends on what your current state is, right? If you have a fairly flat network, then you'd probably want to, you have to do a little bit of work on that. But I think that the way most customers want to get started is it's not a big bang. They would say, all right, great, we love this architecture. We're going to start with these 3 or 5 mission critical applications and these 200 system administrators. That kind of scope is much more manageable. And the way it can get crazy complex when you have real world, very messy enterprise network topologies. But in general, it's straightforward to say, okay, for example, I want to set it up so that to get to port 22 on these servers, you can only go through the gateway. But to get to port 443, you can go your regular way. So now all of a sudden you've sliced this down in such a way that you can have a smaller population of users, and it's a much more manageable rollout.
So, so we're talking about all these fancy new technologies, but what happens if you are, say, a financial firm and you have mainframes, or you have huge ass Oracle databases that, these are all legacy junk that I don't say junk. I mean,
No, you did say Oracle. So.
sorry. Well, yes, but mainframes are not junk. Sorry, Soldier Fortran. I'm sorry, Big Indian. So how do you work with those kinds of old legacy technologies that are still fairly well used in certain verticals, and still have this kind of connectivity? I mean, obviously, I don't want to be able to connect directly to a mainframe from my computer at home, do I?
Yeah, I don't know. Do you?
Well, I would hope there's a little more
Some people might.
control.
Well, it's if you think about what the gateway is doing, it's effectively it's a very fine-grained and dynamic firewall, and it can essentially handle um, any network protocol. So essentially what happens is you run sort of some application on your device. It might be a web browser, it might be an SSH client, or it might be, let's say, your 3270 terminal emulator, Brian.
Mm-hmm.
And that, whatever mechanism that uses to connect outbound, it's going to be TCP or UDP or one of those two protocols most likely.
Sure.
Effectively what happens is that traffic then gets tunneled through this mutual TLS tunnel to the gateway. The gateway then reconstitutes those packets and spits them out the other side, and to the application or system they're connecting to, it's transparent. You can even have individually assigned IP addresses, so that to the target application it looks like you're directly connected to it on the local network.
Okay. Very nice.
So you say that Amanda can get to 443 and 22, but Brian, he doesn't deserve to get on port 22. Now, who's doing the blocking?
So the blocking happens at, again, it depends a little bit on the network implementation, but effectively the gateway won't allow traffic through to the target application and to port 22 in Brian's case.
Okay, so all the traffic has to go through a gateway. It can't be point to point.
Correct.
Okay. So that would also mean that, like, if you got this perimeter, software-defined perimeter, you're not, if malware was infecting a system, it couldn't automatically generate a reverse shell out, right? Because the security gateway would obviously block that before it was able to get out where it was going.
The use case that we've been talking about is, and that the SDP community has largely been focused on, is user to service access. There's potentially two ways we can interpret your question. So if we think about server to server communications, while that is it's mentioned in the original SDP specification, that's generally not how organizations have applied it. Now, that's something that we are going to be talking about in version 2 of the spec. In general, people are not using SDP for that today. The second piece of your question, I think, was about perhaps if you got malware on a user's device. That really depends on the vendor, but in general, and if you're trying to reach out to target applications that are not protected by gateways, oftentimes that's out of scope. But again, it depends. We have customers who ask us to basically lock down the device and control all the traffic.
Okay.
So if you have a VPN, you can disable split tunneling, which means that effectively that user is on that particular network. They can't go to Google, say, if that network can't go to Google. Is there a way you can eliminate that? Software-defined perimeter can eliminate split tunneling as well, kind of the same way?
Yes.
Okay, so once they communicate, like say I'm communicating with server X, maybe my rule set says that I can't communicate to anything else while I'm communicating to server X. So that's definitely doable, right?
Correct. Exactly. That's often a requirement for example, in PCI environments where you have to lock that down.
Yep. Okay. So let's say I'm a regular company. I've got 400 or 500 people. I've been in business for about 10 years, and I have a traditional network with a firewall, a WAF, a web proxy. I've got network segmentation and all that stuff. And then let's say my CIO comes in one week and he's like, "I heard this thing at CSA called software defined perimeter. Let's do that." what would be some of the first steps that you'd want to do to get that initiative started? And how mature does your company have to be able to push that? I mean, are we talking like you've got to have all your assets, notified? I mean, I'm thinking along the lines of CIS top 20, but I mean, obviously if you can't get a handle on your assets, you probably shouldn't be doing software defined perimeter. Am I correct?
It really depends on the use case. And I mean, if your IT and security environments are out of control, then this is probably not your first order problem, right? Your hair's on fire. But we've seen customers get started with a number of different ways. So one very easy one is VPN replacement. It's essentially a one-for-one replacement. SDP does a lot more, but it's very easy from a user perspective because, I'm just running this piece of software over here instead of that one, but I still connect to the corporate network. And from the user's perspective, they're still getting to applications A, B, and C. They never even try to get to other applications. So as long as that simple policy is set up, their experience is preserved. So that's one very simple scenario. Another one is where organizations are considering a privileged access management solution. And PAM solutions as password vaults are terrific. As network security solutions, that's not their strength. So we see organizations say, you know what, we need to lock things down for our administrators for SSH access into these servers, and we want to have it be dynamic. And I'll give you an example. We have one customer that's a service provider. They have a policy that, and they're managing, of course, hundreds or thousands of servers on behalf of their customers. They don't want their administrators to have 24/7 access to those customer servers, but of course they need it on occasion. So they have a policy that will dynamically call out to their ITSM help desk, make an API call, and determine effectively, is there an open ticket that matches this user and that target customer system? If so, I'm going to allow the admin to connect. If not, I'm going to block it. So that's a fairly advanced scenario, but it's an example of taking these high-risk environments and these privileged users and trying to control them. And the third common use case is for cloud environments. As organizations move up to Azure or AWS, it's a different set of security tools, and in some ways they're fairly restrictive. So they want to be able to take this user or identity-centric approach.
Okay.
So there's an agent on the endpoints. Is there also an agent on the server, and what is their role?
So
are they different? Is it the same agent?
In general, the gateway does not. The way that most vendors have implemented this, the gateway does not run on the host. It runs inline at the network gateway. So what it would be if we talk about AWS, it would sit in the ingress point into their VPC. You would set up the security group for the applications running in that VPC to only accept traffic from the gateway's private IP address. And therefore, the only way you can get to that is by having a secure tunnel and a policy on the gateway to allow you to get through to that.
Okay, so I do have an agent on my laptop, though, right?
Yes, and it's akin to again, I'm generalizing, akin to a VPN client in terms of scope and size, things like that.
Mm-hmm.
Okay, so what can it do and what can it not do? Is it just in charge of connecting to the gateway, and that's it?
Well, it connects both to the controller for authentication and to the gateway, and it probably has the ability to interrogate your device to capture attributes. So a common request from enterprises, for example, I want to check whether my antivirus software is running. I want to check my OS patch level. Those are then attributes that can be included in an access policy.
Okay, and what about the server? Does that have an agent as well?
Generally not. There's some vendors have architected things a little bit differently, where essentially there's an agent on each server, but most vendors have done it with an inline gateway that sits in front of the servers. And the beauty of that approach is it's much easier to roll out incrementally because all the traffic that goes from the gateway to the server is its normal protocol. It's unchanged, so that any other systems you have in place, like a network scanner or an IDS or something like that, those can just work on that traffic after it comes out of the TOS tunnel.
Yeah, I was wondering how you were going to implement things like web application services or APIs or something if the agent has to connect to the box every time. You couldn't have a website behind something like this because you'd have to have a packet on each one of these. So you're still going to have some things not, in front, not with the security gateway in front of it, right? There's still going to be some things that you're going to have to, model in the traditional sense.
Yeah, I think so. It depends on what the application is and whether you want and need this level of security for authorized users. Obviously, if it's an e-commerce site or something like that, you don't want to put a barrier in front of people and require them to onboard a device and authenticate. But for other high value applications, you certainly might.
Cool. All right. So you mentioned the CSA. You guys helped build version 1 of that. I say you guys, but I mean you and your organization helped CSA do that. I'm sure that this was like HTML5, where there's a bunch of industry people, industry companies getting together to help formulate these standards. What you said version 2 is coming out soon. Is there a place where people can get to that and do like an RFP or something like that?
Yeah. So if you look at the Cloud Security Alliance website and look for the Software Defined Perimeter Working Group, that's where you'll find an overview and a link to the Basecamp site. That's the collaboration community and the platform that we use for this. Well, so we just kicked off this process a couple of months ago, so it's still early days, and our goal is to get something out by the end of this year. This is an open process, so it's effectively a public process we're talking about and debating scope and the content of the specification.
Mm-hmm. Okay. So in my research, I found this thing called Jericho, which appears to be fairly dated. I don't know if they're still around or not, but they talked about perimeterization too. During our meeting before the podcast, I asked about open source solutions, and I know I don't mean to shoot you in the foot here, and I'm sure your product is the best ever, but for people who maybe want to try this out before they actually buy a more legit product, is there an open source type architecture or solution out there that they could to test drive this on, or maybe like a home user? Maybe a home user wanted to do something like this. I could definitely see something like this for home use if you wanted to be able to access your systems inside your own home network.
Like a super small business too.
Sure.
Don't usually have that.
Yeah.
Yeah, absolutely. So yeah, there is an open source version of this. The company's called Waverly Labs, and it's up in a public repository on GitHub. And I would encourage folks to take a look at that. We're obviously a for-profit enterprise, and we charge for our solution, but we do have a version of our software in the AWS marketplace that's available with a free trial, and it's pretty inexpensive if folks want to kind of get started and try things out.
Okay. And you guys obviously do evaluations and stuff if somebody wanted to.
That's right.
To reach out to
That's
you
right.
directly. Okay.
Yeah, and then to answer your question about the Jericho Forum, yeah, they've shut down. It's kind of a mission accomplished type thing, and I mean that quite sincerely. In that they really came up with some very similar concepts of deperimeterization about, I think it was close to 10 years ago, and they kind of shut down because they concluded their mission of designing this and communicating out to the world the need for it. And I think there were really over the last 10 years a number of different organizations that have talked about and thought about this with, I don't know if they were completely independent of one another, but certainly not with a lot of collaboration. So you look at the Jericho Forum, you look at what the folks at Forrester Research did with Zero Trust, Google with their Beyond Corp initiative, the folks at the CSA around the software defined perimeter. It's great to see these things starting to gel and be at least philosophically aligned and starting to get some real momentum in the marketplace.
Do you think they were just ahead of the curve?
Yeah.
That's why they
like
too advanced for the enterprise environments that they were trying to get it going with?
Yeah, I think that's part of it. Yeah, and I think that perhaps we had to wait for the threat landscape to catch up with. Unfortunately, it has.
Yeah.
Okay. Mr. Betcher, do you have any other thoughts or questions?
No.
Wow. So this was pretty good. I Okay, so I have another question about provisioning. Let's say you've got somebody who's coming from the outside. What does provisioning a new host look like, and on average, how long does something like that take? Let's say you've got a third party. He needs to gain access to this, but he doesn't want to drive into your IT's department. Is it something as similar as emailing him the keys and getting synced up and everything?
Yeah, it's pretty straightforward, and it's generally installation of the client, some out-of-band mechanism for communicating the shared secret, and then just the installer that runs and takes that as a parameter, and then they're set up. Now, clearly, whatever identity system is used to authenticate the user, they would need to be part of that, and whatever policies that user would fall into would, of course, need to be set up.
Fantastic. Okay. All right. Well, Ms. Berlin, Mr. Betcher, do you have any other questions for Jason, Mr. Garbis?
That's it for me.
Okay.
Nope.
All right. Well, I was very interested in hearing all of this from Sean is a friend of mine. I've met him up here just recently. Really good guy, and when he told me about you, I knew I had to talk to you about this because I had never heard of it before, and I was wondering if it was just some fancy bolted on to software defined networking. So I'm glad it sounds a little better than software defined networking, because all I've heard about software defined networking is that it's the apocalypse and it's the end of time. So yeah. So okay, so let's say people wanted to get a hold of you, maybe to talk about this offline, or with the CSA stuff, or even if let's say they are looking for a solution like this and they wanted to talk to you or your company, how would they go about doing so?
Well, people can always reach out to me just on Twitter at Jason Garbis. Send me a direct message and we'll bootstrap it from there. Our company is cryptzone.com, and we got a bunch of information on the site, and happy to engage with you so you can learn more and try things out.
Okay. So before I go, if somebody, let's say a small to medium business, wanted to engage in your organization, how pricey is something like this? Are we talking like Oracle type prices, or is it based on piecemeal, like 100 servers? Is it a volume based licensing? How do you guys do stuff like that?
Different vendors charge differently, and generally what you see is some sort of per user pricing. What we found is when you look at the types of solutions that it's replacing, combined with the labor cost and the increased security that you're getting, that it offers a very good value. So it's yeah.
Cool. No, we don't do vendor talks here all the time, but it's nice to find out how if everybody's pricing it the same, or if So yeah, if you're interested in doing this, you can either give Jason a call, or you can try the Waverly thing first. Whatever Waverly's thing is not going to be the same experience as what you get with Jason and his team. So. So Jason, you said you're doing stuff with CSA. Are you going to be somewhere in the near future where people could hear you talk more about this?
Yeah, we're going to be at a one-day CSA summit in Boston on April 5th, 2017. And I won't be giving a talk on this, but I will be part of a panel that's talking about securely exposing your services. And I'm sure this type of thing will come up. Excellent.
All right. So yeah, you can reach out to Jason, or if you're going to the CSA Congress, that'll be sweet. In Boston in April, that won't be so bad. Okay. Jason, thank you for coming on the show. I appreciate you coming on. If you ever want to come back on, we tell this of our guests, but it doesn't make it any less true that if you've got something else or anything else you want to talk about with software defined perimeter, please feel free to reach out and get a hold of us.
Will do. Thank you, Brian. Thank
you,
Brian and Amanda.
Yeah, thank you.
All right. So, Miss Amanda, as always, if people wanted to get a hold of you, how would they go about doing so?
It's at InfoSystir, INFOSYSTIR, on Twitter and everything else.
Awesome. Okay. Mr. Betcher, how would they go about doing the same for you and contacting you?
Well, I am at on Twitter at Betcherpwned, BOETTCHERPWNED, and I will also be at DerbyCon. Now, if you're at DerbyCon and you're listening to this, you better come by and say hi.
Right. Wow. I'll be there too.
You better.
Or he will give you the squinty, flinty eye like you nobody's business. Oh, and
because I can tell if we make eye contact and you know who I am, but you don't come.
That's totally what I'm doing.
Yeah.
It's
on.
Yeah, it's on. Yeah. So you can follow BreakSec. We're at Twitter at BreakSec, BRAKESEC. You can follow me specifically at Brian Brake, BRYANBRAKE. I spell it correctly. So we do have a Slack, and holy cow, Slack has blown up over the past 2 weeks. We've gotten probably 20 to 30% more people. It's amazing. We've got such luminaries as myself and Mr. Betcher on there. No, I'm just kidding. We've got a lot going on, man. I mean, in the last few days, we've started another war game channel. One of our young punks in the channel there, Chris, has started up the Bandit War Game channel. He was very interested in running something himself, so there's 17 people in that channel, and they're actually running the CTF right now, which it's Thursday at about 6 p.m. my time Pacific. He just said, hey, I want to start this, so we appreciate his initiative and his go-gettingness and his self-startingness.
Heck yeah.
Yeah, it's awesome. We're doing a CTF club. Natasha's still going on. I think we're stuck around level 16 somewhere. So if you have experience with blind SQL injection or learning how to
scripting blind SQL injection,
yes, and nesting greps, which I think is how we figure out how to get through level 16. If you have experience with that, please join us, please. We need help, please. So yeah, you can sign up to Slack by going to https. breaksec.signup.team. You can join us there, and we've got a lot of people on there, a lot of great conversation. We have a job board, we have a malware board, we have a channel for talking about pen testing, we have a DFear board, so if you want to talk about DFear, we had some pretty interesting conversations about recovering data. Somebody deleted off of a Canon movie camera, so they're running some DFear tools to try to grab the data back off of that. Our book club's going on. Of course, last week you heard Amanda and Lee talking about a Defensive Security Handbook. We're running through chapters 2 and 3 of that this weekend.
I think just 2.
Just 2? Okay, because it's
and then 3 and 4.
Okay, so it's going to be on asset management, but
yeah,
you can. I mean, what book club can you go to where one of the authors is the actual runner of the book club? So,
and I'll actually be driving to Florida and calling into the book club.
Oh my God.
On the road, and the next weekend, I'll be driving from Florida back to Ohio.
Oh my goodness!
When I'm on the second one.
Okay. Well, please be careful with that. So yeah, we're doing a lot of great stuff over there. So please feel free to join us. We have a Patreon. I appreciate everybody who's been giving money. We got some new people giving money. Colby and Ed gave some money to us to help offset some costs we do for just getting the podcast started and hosted and everything. So that was great. If you want to join us on there, we have a link in the Slack if you want to do that for giving us a little tip in the tip jar. Oh, yes, we're making it official. So Matt Domko, who you might have heard talk to me at B-Side Seattle, has agreed to do a Python class for us. So what we're going to do is we're going to either...
What?
I know, right?
Yeah.
That's what you get for not coming to the club meetings, Mr. Betcher. So it's basically like an intro to Python, or it's going to be talking about a bit of Python. He works for a company that actually teaches classes, but I asked him if he wanted to do something because he does a lot of PowerShell stuff. So he was wanting to stretch his muscles a little bit with the Python class. So far, we've not asked for anything for the class, so it's going to be a completely free class, but I'm going to have to limit it probably to probably less than 20 people. So if you're super interested in learning Python, if you're, picking the brain of somebody who is well-versed in teaching and all that, Matt is going to be teaching a class for us online. That will start. I have it set for April 6th, Thursday, April 6th. At that's not right. I have the date here. It's going to start at 5 p.m. Pacific time on Thursday night and go for an hour. He will release a syllabus, and I have suggested to him that he has some kind of Python book to follow, even though he says, yeah, we're not going to need that. The only thing I think you're going to need is you can either use an IDE, any kind of Python IDE like Charm, or if you feel comfortable enough doing it in VI or whatever, that's fine. So just bring yourself. We're going to have a channel that's going to be set up for that. So once I lock that channel, you won't be able to get into the class. So that will be available, and more information will be coming as it happens. So please join our Slack at breakstack.signup.team and get involved if you want to do that.
There's like 11 channels, and there's no less than 40 people on each channel.
I know, dude. I know. And we our general channel has like 250 people. I don't know what happened. It was like I went somewhere and we had like 100.
I had a tweet storm last night too. I was tweeting back and forth with a bunch of people.
All right, so Amanda,
a whole bunch of people showed. They're like, yeah.
Amanda's the reason we're all popular now.
No, so. just yesterday. Like just yesterday.
Oh, okay. So Amanda's the reason we're all popular now. So.
Right. Before you weren't.
Yeah, if we're not right, we got to ride somebody's coattails. Yeah. So.
Right.
Yeah, right on. So let's see. We're on. Oh God. So real quick, we're on. We just got on iHeartRadio. We're on TuneIn Radio app. We're on Player.fm, SoundCloud. We're on. We do have some LinkedIn stuff. I mean, there's TuneIn Radio is really great. We have an RSS feed. All of those are in our show notes there. You can find that stuff available online. So, come in and join us on Slack. Hit us up on Twitter, whatever. It's all great. Really great talk with Chris tonight. Not Chris. Jason. Damn it. I'm looking at Chris, the young punk in his band at War Game here. So, Jason, great talking to him. Thank you for joining us. And that was it for this week on the show here. So for Breaking Down Security World Headquarters, have a great week, and we'll talk to you again soon.
Bye-bye.
Bye, everybody.